Cool. I'll look at
Agreed.
it. Research.
Hey, angling, alchemy. I was wondering if you knew any, if you thought that the rainbows were part of the toroidal flux, I guess, lines, because they come up from underneath us too and above us. But when you go up with the drone, you can actually see it's not a bow; it's a whole circle, and it stays
It's a
level with the
circle.
drone.
Yep. Yeah, I think it's just a reflection through the firmament. It's my 2 cents, and that's why also when you go up, it makes a circle because the firmament is a lens. I can't prove any of that though.
Right. I wasn't sure. I was thinking, okay, well, maybe the toroidal magnetic field lines are causing somewhat of the effect, along with ether, being charged with it, something like that.
Yeah, I just think it's an optical phenomenon. From the sun, the firmament. Light is ether, of course. It's a wave in the ether at a particular frequency. But yeah, I don't think it's necessarily related to the field lines. However, the movement of the sun might be. I've kind of been thinking about it, and I haven't gone down the road to check out to see if it works out, but it kind of works out that, like, if you think about the toroid, like, and look at that dual pole model, like, you could make, like, the circuit of the sun follow that toroidal pattern depending on where you're viewing it from. So the sun could be moving within that toroidal geometry pattern, but, I mean, it measures that way, certainly. In fact, I'll post a video about exactly that. How when you map the sun, it makes a toroid, a donut.
If you think about it, considering all of the land from the center outward is kind of expanded, like in the dimensions, like it's larger, right? So the area that we think of as Antarctica, that's just in one direction, and that's one isolated location. Like there is a vast, and if we were to like maybe find out how things appear and behave in those areas all the way around, it could be square, it could be circular. I mean, I'm not saying any shape to it. We're just talking about the surface too, right? I'm not saying Earth is any shape. But I'm just saying, like, when we talk about the South or Antarctica, that's just one small, minute location in a vast expanse around us. So how we see things happening, like in the quote South unquote towards Antarctica, like there could be the same thing going on in different locations that's independent of that one, of that location. Like that could be happening in several different directions.
Well, isn't there two North Poles, or there's a polar north, and then there's the center of the vortex of the toroidal field, which would be outside of our continents or outside of Antarctica, beyond Antarctica? Am I thinking about this right? So if we think of not just our continents, but beyond Antarctica being other continents, and being that would just suppose that the moon is a map of, we've all heard this, right? If that's the case, then the center, the true North Pole, would be far from our Middle Earth. It would be, well, not that far really, but it would be a little journey on an airship, right? And then our North Pole, what we think of as our North Pole, would be something completely different than the true North Pole or the vortex part of the toroidal field. We wouldn't even be near that. So we wouldn't, unless you travel past Antarctica to the true center of the vortex, then we wouldn't know. And I think I've read or heard accounts before of sailors who've tried to navigate it. And it was that vortex that they were trying to navigate, not our North Pole, what we think of as our North Pole.
Right. It wouldn't surprise me. It really wouldn't. I mean, we don't know. I do know that there's past writings or past documentation that and this isn't just like an article or, someone writing a diary or a journal or even trying to get their scientific paper credit. This is in the Encyclopedia Britannica, right? It says that in the encyclopedia, I think it was 1965, or maybe it wasn't. I don't know. I could find it though. I think I've posted it before. But it stated that it was about 13,000 feet high, that the ceiling was about 13,000 feet high at about the 85th parallel. Now, if it's 13,000 feet high and that's the limits of it there, then, I mean, I don't know. That's the question though. They don't, like, even if you book trips down there, it's very regulated and you have to specifically ask to go further than Union Glacier. And when you go further than that, you can't fly drones. So, I mean, and there's stories of planes crashing and hitting something solid, like whether it's solid or not, like they were crashing into it, according to the stories. And the question remains, like, what happens beyond 85th? Does it continue to decline, or does it just like dip like a wave and just rise back up again? Is there another one? I know there's alleged a southern gate.
So, truth prevails. Do you still drink rainwater?
Well, I used to get that's a little. I used to get water from a spring.
Please don't do that. Please don't just derail the topic with some random thing, dude. They were right in the flow of a really good combo. We could shift to that, but super disruptive.
Yeah, I was
just wanted
thinking the same thing. I just figured I'd answer it real quick, and hopefully he wouldn't like try to keep derailing. But hard derail.
I mean, I wasn't trying to derail. I was just trying to join the conversation.
Well, that's not joining the conversation. That's derailing because it's a completely different topic out of the blue. Has nothing to do with what they were talking about, which is 85 degrees south and Antarctica. You have to understand there's a whole audience of people listening to those ideas, and we were flowing with it. So just a hard rail into something about drinking rainwater is just a derail.
Totally derailed.
So I posted that video in the chat. If you wanted to, if that dude that asked me about the, like the lights in the sky and moving in, with the magnetic field lines or toroidal lines, I highlighted it there. It started at 128. It's just a 2-minute chunk, but it's a great 2 minutes.
Thanks. I'll check it out.
I mean, it probably wouldn't even hurt to stream it, Geo, if you wanted to. You want to twist your arm or anything.
I mean, I just thought the rainwater topic was interesting because that's one of the few ways you can guarantee the water is fluoride free.
What if they chemtrailed your water?
But the problem is they're trying to make it illegal. They're trying to make it so you can't have your own water. You have to drink their water.
Well, that sounds totally dystopian. I suggest you don't comply.
Amen.
That 2-minute chunk is great because a lot of people say, well, flat earthers haven't done anything and they don't make observations or anything like that. And these dudes did a crazy amount of work. Just all about the sun.
Yeah, I guess only some people are allowed to talk in this fucking room because otherwise it's derailing. Because we like to control conversation with dead air.
It's not about controlling conversations. Like there were like 3 or 4, maybe even 5 people altogether that put input on a conversation about the magnetic fields of the Earth and comparing it to other magnetic fields, talking about the different ones and Antarctica, what goes on in the South. Like none of that had anything to do with that. So do you have anything to say about any of that was actually a conversation? Like I know you've got input on it.
I'm not a flat earther, so I don't really believe in your magnetic fields or whatever.
They're not mine, and they're not exclusive to flat Earth. But okay, fair enough. Like maybe, yeah, just allow the conversation to go on and wait until it's appropriate, I guess.
You're not a relativist, right?
You're kind of cutting out, Mr. Angling.
Don't believe in magnetic fields, huh? You want a chance to retract that statement?
I mean, I don't even. I mean, they're talking about like magnetic fields or something. Like, I mean, I don't really have anything to say about magnetic fields.
Yeah, that one you were claiming where like they say the dome comes down to like 13,000 feet. I have a hard time thinking that's probably true, but like there's that one reference to it that you mentioned, Truth Prevails, because I don't know. I mean, they fly into that 90-degree south place. I mean, like ALE has a camp there. I would really highly doubt that they like can't go above 13,000. You know, but
I mean,
yeah, that reference. Oh, go ahead.
well, I don't know how they do. They, I mean, when they fly, do they just stay low, or do they get in a different plane? I mean, how do they go? Because when they go to Union, I don't know what's the latitude of Union Glacier. See, I haven't even looked into this into like comparing the 85th parallel to Union Glacier, where Union Glacier's at. But I do know that in order to go, according to the people who went, right, in order to go further south, like you've got to book specifically, and then don't you have to like stop there and then transit to the further part? So I'm not sure if they do fly higher than 13,000 feet beyond that point. Like if they fly, maybe it's in a, I don't know. I don't know how they do
No,
that.
they're flying at they're flying high because the jets they're using would burn fuel like crazy if they stayed low. They're flying at the same altitudes they would normally fly at.
I mean, they have other aircraft down there that they use to get around, and but whatever. I mean, it is true that you have to book separately and it very specifically, and you can't use drones. You can't like beyond certain. What is it? 90? Is it 85 or 90? See, I don't know what is Union Glacier at.
It's almost 80, just short of 80.
And it's 20. They claim it's 2,300 feet above sea level.
And what's his face wasn't able to bring his drone, and he flew that thing around.
Pretty sure you can't. You can't fly them past 90 though.
If you fly them past 90, you start coming back
Well,
outside.
past 90 would be going. Yeah, you'd be going back into the 80s again. All directions would be north.
Like I said, you can't do it.
Is that the dual pole has an explanation for the south as to how the south is laid out, whereas the AE sort of has like the ring around the outside. So that's the difference. Like on this one I'm posting, which actually kind of shows the field lines all coming out from the center. It shows sort of a center base, but it has that general dual pole type of layout. But any map like that like maintains Antarctica as an actual continent, you know, in the south. So like this one here as well. So I mean, if you were to, you could still travel across it. You could ski across it. You know, you could even go from like South America across it and go over to Australia. But the only thing you couldn't do is go from like South Africa across the South Pole, and then keep going south, and then end up in the north. That's what the globe would require, or that's what you know would have to be a globe for that, unless there's some kind of Pac-Man thing, which I'm not suggesting that you warp across or anything. You know, if you were to go straight down to the 6 o'clock position and then show up at the 12 o'clock.
But I don't. Why wouldn't the same thing? Why wouldn't the same problem be true for going east to west? Oh wait, sorry. Maybe I'm looking at the bottom one. No, it'd be the same for the top. Like on the top one, you could fly from south. I'm trying to think of ones where we know there's flights, but that would go like from South America and fly to say like Australia or Japan or something. That would be a problem for that map, right? Because you'd have to like warp off one edge to the other.
Yeah, I think it's a flight from Sydney to Buenos Aires or something like that.
Yeah, you could still do that flight on this.
How would that work? Oh, you're saying you'd ring around the outside of it.
Yeah, it's the same. I think I had this image that I saved at one point. I mean, those would be the two possibilities of getting there. But the orange one there, that's like what they call a small circle on a globe. Small circle route. Like if you were to go like on a globe, if you were to go to 40 degrees north and then stay on 40 north and then circumnavigate around, that's a small circle route is what it's called. You know, there's a great circle and a small circle. So basically those are the equivalent of a small circle route on a globe. So yeah, you would still be turning just like you would on a globe, but you would just be on a planar surface instead of on a ball.
But why can't you just do that from the south to the north also? Just do a big loop around the outside, I guess.
Yeah. Yeah, you could go around either pole. But... Yeah, go ahead.
I was going to say it's important to remember how you'd navigate as well. You know, like you look at the map, yeah, it's a problem. It would have to Pac-Man, but what you'd actually be using to navigate would be either be the stars or magnetic field lines. And you can see how if you just followed those, like you wouldn't know the difference. You know, the distance obviously might be an issue, but when we're talking about plane flights, we know some of that's fudged anyway in the first place. So I haven't looked into it close enough to know if that margin for error, if you will, is like, could it be this dual pole model or something? But it seems like, you know, like you look at it like, yeah, you have the Pac-Man or whatever, but in all practicality, nobody actually navigates that way. Nobody gets on the equator and says, I'm going to navigate dead east on the equator and see what happens. Like we don't, you know.
Like we track GPS. Like this thing shows the graticule, right? So it maintains the little lines that and those lines are going to place different cities or whatever at that latitude, at that longitude. So when you go to fly, you're gonna if you're doing a flight, you're gonna map out a route using great circle routes, which is the Haberstein formula, and that's going to place you right through the graticule. And it doesn't matter which projection of a map you use, that's going to be the fastest way to get you from point A to point B. And like you could just redraw you could redraw those great circle routes on this map or any other one, but they're going to look weird. They're just going to look weird on any map, except if you see them on a globe, they tend to look pretty straight.
Yeah. And the other thing these two maps do is completely distort the true dimensions of most of the southern continents. Australia is completely off the show. Even worse.
I mean, sure, yeah, in general.
Well, the thing is that the dual pole has an explanation for the south as to how the south is laid out, whereas the AE sort of has like the ring around the outside. So that's the difference. Like on this one I'm posting, which actually kind of shows the field lines all coming out from the center. It shows sort of a center base, but it has that general dual pole type of layout. But any map like that like maintains Antarctica as an actual continent, you know, in the south. So like this one here as well. So I mean, if you were to, you could still travel across it. You could ski across it. You know, you could even go from like South America across it and go over to Australia. But the only thing you couldn't do is go from like South Africa across the South Pole, and then keep going south, and then end up in the north. That's what the globe would require, or that's what you know would have to be a globe for that, unless there's some kind of Pac-Man thing, which I'm not suggesting that you warp across or anything. You know, if you were to go straight down to the 6 o'clock position and then show up at the 12 o'clock.
But why wouldn't the same problem be true for going east to west? Oh wait, sorry. Maybe I'm looking at the bottom one. No, it'd be the same for the top. Like on the top one, you could fly from south. I'm trying to think of ones where we know there's flights, but that would go like from South America and fly to say like Australia or Japan or something. That would be a problem for that map, right? Because you'd have to like warp off one edge to the other.
Yeah, I think there's a flight from Sydney to Buenos Aires or something like that.
Yeah, you could still do that flight on this.
How would that work? Oh, you're saying you'd ring around the outside of it.
Yeah, it's the same. Yeah, I think I have this image that I'd saved at one point. I mean, those would be the two possibilities of getting there. But the orange one there, that's like what they call a small circle on a globe, small circle route. Like if you were to go like on a globe, if you were to go to 40 degrees north and then stay on 40 north and then circle small circle on a globe, small circle route. Like if you were to go like on a globe, if you were to go to 40 degrees north and then stay on 40 north and then circumnavigate around, that's a small circle route is what it's called. You know, there's the great circle and the small circle. So basically those are the equivalent of a small circle route on a globe. So yeah, you would still be turning just like you would on a globe, but you would just be on a planar surface instead of on a ball.
But why couldn't you just do that from the south to the north also? Just loop, do a big loop around the outside, I guess.
Yeah. Yeah, you could go around either pole,
It's
but
important.
yeah, go ahead.
I was gonna say it's important to remember how you'd navigate as well. You know, like you look at the map. Yeah, it's a problem. It would have to Pac-Man, but what you'd actually be using to navigate would either be the stars or magnetic field lines. And you can see how if you just followed those, like you wouldn't know the difference. You know, the distance obviously might be an issue, but when we're talking about plane flights, we know some of that's fudged anyway in the first place. So I haven't looked into it close enough to know if that margin for error, if you will, is like, could it be this dual pole model or something? But it seems like, you know, like you look at it like, yeah, you'd have to Pac-Man or whatever, but in all practicality, nobody actually navigates that way. Nobody gets on the equator and says, I'm going to navigate dead east on the equator and see what happens. Like we don't, you know.
Like we track GPS, like this thing shows the graticule, right? So it maintains the little lines that, and those lines are going to place different cities or whatever at that latitude, at that longitude. So when you go to fly, you're gonna if you're doing a flight, you're gonna map out a route using great circle routes, which is the Haberstein formula, and that's gonna place you right through the graticule. And it doesn't matter which projection of a map you use, that's gonna be the fastest way to get you from point A to point B. And like you could just redraw it. You could redraw those great circle routes on this map or any other one, but they're gonna look weird. They're just gonna look weird on any map, except if you see them on a globe, they tend to look pretty straight.
Yeah. And the other thing these two maps do is completely distort the true dimensions of most of the southern continents. Australia is completely off the show, even worse than it is on the AE map.
Yeah, it's not really relevant because there's a bunch of other projections that don't distort them. This is just one that happens to be distorted. If you look on the list of like map projections on Wikipedia, there's at least like half of them that are similar to this type of layout, and they're all slightly different. So yeah, that one does have what would look like a warped Australia, but there's other ones that don't have that look pretty similar to what the globe claims. This is not the
Something will be warped though, right? Has to be.
Well, I mean, for our purposes, you know, like, you know, this is just fine. This is just like a depiction or an illustration, you know. Like if you wanted to change the shape of Australia on this map to something you'd think is more appropriate, I don't think anybody here is going to be up in arms about it.
Yeah, then it's going to break everything else you observe.
Yeah, I don't think anyone's claiming that that's the exact continents either. We're talking about the general layout. I mean, the thing is, like, if you think it's a globe, you can go with the globe, that's fine. But if the truth isn't the globe, then if you're on a truth journey, then you're not really getting close to the truth. So if you want to, you know, and if the Earth is planar and stationary, you know, there's the AE map and then this dual pole. So the AE has 1,000 problems. The dual pole has a few things that would need to be worked out, like the east-west circumnavigation, the exact layout of the continents. But in terms of the Earth being planar, if you were at the North Pole, 85 north or 80 north, or close to it, and you were hanging out, you could travel south, 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 and end up at the South Pole, and then you'd be there. So if it's planar, then that means that the continents are laid out between those poles. And then you have two massive rotation of stars, and the lines are straight at the equator. So there's really no other option of what it could be in terms of being planar. The AE map is highly problematic. I think that's kind of a Psyop really at this point, like in terms of like Globe 2.0 that was sold. They got everyone to latch onto it. So
but this is just an AE map, right? All you've done is you've moved instead of the center being at the North Pole, you've just moved it down to zero latitude, zero longitude. It's the same. I mean, it's gonna have all the same problems that the AE map has. I think what's happened is you just sort of like maybe hid them in water.
No, the difference is this is called a azimuthal equal area. So it's different than an azimuthal equidistant. An azimuthal equidistant is pulled, you know, from the equator at the center and then have equidistant latitude lines going all the way out, et cetera. And then it makes Antarctica the ring around the outside. This is an azimuthal equal area. So it's equal area in the, you know, the northern and the southern half. And this basically makes the Pacific Ocean the ring around the outside. If you notice, it's the Pacific that's the ring around the outside, which is interesting.
Yeah, that's kind of what I was saying. Sorry,
yeah.
cut you off.
Oh, go ahead. No, I was just saying that the thing that's interesting on the globe model, like half of the ball is the Pacific Ocean, like a whole half, like we jokingly call it the blue side of the ball. If you look on Google Earth or whatever, it's like half of the ball is a blue ocean. So for anything to be wrapped around the outside makes like, that's a massive amount of the ball, like half of it, you know? And so if this is actually the case, it would make sense that the massive thing or the ring around the outside is the Pacific Rim, if you will. You know, whereas Antarctica doesn't. I mean, there's no evidence that Antarctica has a ring around the outside that I've seen. In terms of all the camps there, being able to fly to 90 South, like, in terms of Antarctica being this huge. I mean, Antarctica is huge, but yeah. So that's kind of the difference of how this lays it out.
Yeah, I guess my point is that all you're going to do is move. You're just going to move the problem somewhere else. I'll spend some time looking at it, but I mean, I can tell you right off, like flying, say, Hawaii to Japan on this one is going to be really weird. New Zealand. Where's New Zealand? Oh, it's down at the bottom. Like you're just kind of completely whacked out flight times and directions from anywhere in the Pacific. Now the nice thing is there's not as many things in the Pacific, so it's a little harder to find these ones, but they'll be there.
Yeah, but we'd have to know like the exact layout of the continents though to really get into the flights, to know the exact layout. I mean, like I said, like if you look at here I'll post it. It's just the Wikipedia for the list of map projections. I mean, even the Mercator, like more than half of them are this kind of layout. Like where you just have basically the continents, like you have North America in the upper left, South America in the lower left, Europe and Asia in the upper right, Australia in the lower right, and then sort of Africa in the middle. And that's really what the globe is too. You look at the ball, it's like there's Africa in the middle, and then half of the ball is the Pacific Ocean. Now, granted, the globe is wrapped around a globe. The half of it is the continents wrapped around a ball. But anyways, I'm just saying like that general layout. I mean, that is the general layout of the continents. Sorry, I have something in my throat. That is the general layout of the continents. But yeah, I mean, there's difference of it being planar or wrapped on a ball in terms of what you're talking about, the plane flights and stuff. But I'm just saying, like, we'd have to know more in terms of getting that laid out. I mean, Pazza, what happens in an electric field, when the electricity follows those field lines, or the magnetic field? It loops back around. Right? The electricity doesn't have to Pac-Man anywhere. Nothing Pac-Man's off the edge of any field like that. It's an eternal loop.
Yep.
Like in this type of thing, or like a Ferris cell, like if you had like the magnetic field lines, like there's no Pac-Manning electric field. Like the whole thing is a loop. It's looping around both poles.
What's that line CC dash in there?
Plane of inertia.
Well, yeah, right. They're magnetic potential field lines, aren't they?
Gonna ask you though, like I know, like I mean, there are still issues with it. Like obviously, east-west circumnavigation becomes a question. Like what's going on there? Because like I know, like I mean, there's some people that might say Pac-Man, but I know like New Perspective says no Pac-Man. A lot of people are saying no Pac-Man, or the people that are considering it. But I'm just saying there is the east-west circumnavigation. But if we just leave those things out for a minute, I just want to ask you, like, and I admit that there's questions there too, like what happens with that. But I just want to ask you, like, don't you think in a way though that for a planar layout, and I know the thing you mentioned that you made like kind of has sort of an idea like that, although you were saying there's some kind of a transition or you have your own way of describing, but like if you have like on the globe thing, the northern hemisphere, as it were, which is the star rotations coming out from the north. And then on the globe, you have your southern hemisphere, the star rotations coming, the southern star trails coming out from the south. Because like in the same way you can get your latitude using Polaris, you can get your latitude using the Southern Cross and so on in the south, in a symmetrical way. I just want to ask you, like with that dual pole, don't you think like in a general way it more well represents like, the way that the globe claims that there's the upper hemisphere, the lower hemisphere, and so on. Yeah, like that thing you just posted. I'm just asking, like with a dual pole layout, don't you think that does more properly represent the South? Even if we leave the east-west circumnavigation for a minute out of it and some of these other things, I'm just saying, or the straight on the equator circumnavigation, because you could still circumnavigate around the North Pole or around the South Pole. I guess my question is, don't you think that general layout more properly represents what they would call the southern hemisphere of the globe? With the two.
Yeah, like I said.
Yeah.
Like I said, if we're looking at this from a perspective of problem solving, and you're trying to solve the problem of given all the evidence of what the Earth is, what is the Earth, right? And then obviously from y'all's perspective, you had to drop the globe from, say, okay, it can't be a globe. Okay, it's a flat plane. How does it work? Then yeah, that's what I'm saying. Like that's why, from what I can come up with, that's the only way I can make it even remotely work, is to have these two poles, but they have to be identical in size, like you said, because the sizes of the latitudes are seemingly parallel. They mirror each other in the north and south, so they're supposedly the same. These are the same size circles, which is why, like I said, just putting them side by side makes it work. But then you run into the problem of how do you connect those two sides together. So there's still problems. But yeah, to answer your question, that's the only way I can make it work, is with two separate hemispheres side by side, or not side by side, but two separate hemispheres somehow connected.
Yeah. Yeah. Well, and what you mean by how they would connect? See, I just posted. I made that little collage the other day, just playing around, just putting images on it. But it's nothing special. I just threw a couple images together. But are you saying that, like look at that, the Ferricel one, or you're just saying if you have perfect concentric circles from the star trails, how do those perfect circles and latitudes that are all consistent, how do those like kind of start to bend differently near the equator and kind of blend? Is that what you're saying? Like the challenge would be?
Well, I mean, you said earlier about the GPs. There's GPs, 1-for-1 GPs with stars, and from what it seems like, those concentric circles are concentrically circling around the poles. So they start off as small circles, and they get bigger and bigger, and they do that on both sides. So that's what I'm saying. So they're doing the same. They mirror each other in size, seemingly. So that's why I would think that they are the same size as one another. And if this were a computer program, if we weren't worried about reality and we were worried about just making this in a video game, you would just simply make two different worlds. You'd make one world for the North Hemisphere and one world for the Southern Hemisphere. And then when you just like in a video game, when you're going from one hemisphere to the other, you just load the other world, basically.
Why would you need to do that though? But if you have two AE maps basically next to each other, like Titty Earth kind of thing, on a planar surface, what is the problem with why couldn't those blend near the equator?
There would have to be some kind of like let's say let's take any point on the equator, like in Indonesia, and then another point in Africa. At the same time, if somebody is crossing the equator in Indonesia, and somebody at the same time is crossing the equator in Africa, that means that those two, if those are two different hemispheres, they're touching in two different places. You know what I mean? Like there's, and so like there's some kind of magic. And I say magic because there's just not a science that makes it work. So there's some kind of way for these two hemispheres to both exist. And I say next to each other, but it's only because you can cross from one to the other. Yeah, so there's some way for you to cross from one side to the other in multiple places at the same time. And I think that's why people bring up Pac-Man, is because that's one way of describing what would need to happen.
But are you saying because if you have two circles, like, I'm trying to understand what you mean. Are you saying that they would only meet?
My picture. You see how it's connected right there in my picture at South America? Basically, that is a bad drawing, but that's like that they're almost touching where Panama is, basically.
Yeah. So like this right here, this is from Lady Blunt's book, The Zetetic Astronomy, and she's talking about the 24-hour sun in the south and the north. So this is her little diagram for showing the two sun rotations in the north and south. So are you just saying that like if you have two perfect circles, they would only meet in one place like that?
If they were side by side in a spatial, like if they were both two actual disks side by side, yes, they can only be touching at one tangent point, right? Or there'd be a tangent line.
Yeah, but what about like the way electric fields, Ferricels, like I'll post a few kind of thing, but what about like that it's like it blends, the way an electric field is, like once you get closer to the actual, to the center, like the lines, I know what you mean though, like they're not, like basically on this one here, where you have like the circles on the north and south, but then as they get closer to the equator, you get this like vortex where it's sort of like the radius of the circle, I guess, gets larger as you get closer to the equator. So it blends the way an electric field does. So that's what I also think is fascinating about this, is how closely this matches what the actual sky appears to look like, like the actual sky in terms of the star trails at the equator, like just the similarity. the
It's an
similarities.
interesting idea. It just creates a different problem, but I mean, it solves one problem, but it creates a different problem. Because like with mine, I have an explanation for why the sizes and distances and how they work in reality and how they match what's on the these two AE maps. With this, you would have to come up with some reason why it looks like the distances are getting almost infinitely far at the equator between the two sides, right? Because like the circles start off small and then they get infinitely large as you go further out. That's what it seems like.
So you're saying that wouldn't fit with the latitude lines all being consistently spaced from each pole?
Not just the latitude lines, any distances. Like if you take that picture that you have and we make that real places on Earth, like South America, like I said, that's where the closest point is. Then somewhere else that would be Indonesia, but then that kind of distorts the rest of the picture, the rest of the world. I think I'd have to think about it some more. I think I'd have to look at this picture you posted and sort of compare it with the azimuthal equal area map.
If it's a dual pole, I could. I mean, but what if it's not? Like, what if the areas that aren't Antarctica, like all around the perimeter, what if they're doing something different? I mean, that's my question, because we really don't know. There's an example of. I'm just posting some different images of Howard Johnson's Secrets of Magnetism, or magnets, where different types of magnets, different shapes of magnets, because we don't know what the shape of the Earth is. The only thing that we could even possibly determine is what the surface is doing. But anyway, all I'm saying is we don't know. It could be 2, it could be 4, it could be something else. I don't know. But that's what it would look like if there were like this. This is what it looks like coming from. It looks like a square. Okay, and if it's not a square, if it's something else, and I guess it would also matter how the ceiling works with the ground of